Okay, this problem is a little more tricky. This is writing an equation and drawing its graph to model a real-world situation. I may or may not be able to graph this very efficiently because when you're dealing with, real-world problems, a lot of times the units are bigger than I'm able to draw nicely on the fly here. All right, so let's talk. One is driving on the highway. He begins with the trip with 12 gallons of gas in his car. The car uses up 1 gallon of gas every 25 miles. So let's think about this logically, okay? Here's Juan. He's in his car. This is the only way I know how to draw a car, so don't laugh. Or maybe you can laugh. I don't care. Okay, so this is Juan's car. He's driving, okay? And think about it. He's starting with 12 gallons. And as he moves along for every 25 miles, he's going to use up 1 gallon, of gas. Gets 25 miles to the gallon. All right, so I want you to note that this is a little different because normally we add B. But in this case, think about it this way. We're starting with the gallons and we are using the gas as we go along. Okay, so the car uses up 1 gallon of gas every 25 miles. Let G represent the number of gallons of gas he has left in his tank. Okay, so G is what we're going to be solving for because we want to know how much gas he has left in his tank. D is the total distance in miles he has traveled. Okay, well, when you're given a rate, okay, what this is saying, and this is kind of better the way they gave it to you, is I'm used to thinking of miles per gallon when I think about this. But really, if you're thinking about it in terms of gasoline, the way they gave it to us is even better because they're saying for every 1 gallon, you go 25 miles. And we want to get gallons, okay? So we're going to take that 1/25th is our rate. 1 gallon gets 25 miles. All right, and if you're thinking about it, what we're going to do is we are going to put D on the top because however far we've gone, we're going to divide it by 25 to figure out how many gallons we used. And those of you who are good at unit analysis, notice that D would be in miles and it would cancel out and you'd be left with gallons, which is what you want. Okay, so in this case, we're actually starting with 12. And then we are going to subtract, 1/25th of D. Now you can write it like this, 1/25th times D, or you could write it most likely 1 times D is D, so you would simply write D over 25. Come on, pen. Okay, D over 25. And to graph this now, all you would need are some points. So we're going to plug in D and we're going to solve for G. And some really quick trips. We're taking a trip. I'll give you a tip. Really good tip is to pick multiples of the denominator. So let's do 0. 0 isn't a multiple, but 0 is a great number because it's like a nuclear bomb. It makes everything turn to 0. 0 divided by 25 is 0. Let's, plugging it in. 0 divided by 25 is 0. 12 minus 0 is 12. See, that's our beginning point. All right, now let's plug in 25. So we went 25 miles. We plug in 25 here. We're going to get 25 divided by 25, which is 1. And I might write this over here. You're going to get G is equal to 12 minus 25 over 25. That changes to 1, and 12 minus 1 is 11. Get it? For every 25 miles he goes, he's going to lose 1 mile. 1 gallon rather. There you go. So on your graph, these would be, I'm sure in Alex, these are points that you would mark, and then you would make Alex connect the dots. And sorry I had to leave there and make a second video. I had to answer the phone. All right, let's take a look. It says finding the intercepts and rate of change given a graph of a linear function. All right, a machine at a bakery is pouring out flour. The graph shows the amount of flour in grams in the machine versus time in minutes. All right, so in the beginning, it looks like this is 600. Is that 630? Sorry, let me see. I can't quite read that. Can you guys? Let's see. I'm going to see if I can enlarge it. It kind of looks like 630, but it doesn't make sense to me. So let's see. It is 630. Okay. So they're climbing by 70s. 70 plus 70 is 140. Plus 70 is 210. Yeah, they're climbing by 70s. That is an odd amount to climb by, but okay, let's roll with it. Okay, so they're starting with 630 grams. Okay, and then they're pouring out the flour over time. Take a look always at the units. Okay, this is grams of flour, minutes. That's 1 minute, 2 minutes, 3 minutes. Okay, in other words, it takes 3 minutes to pour out 630 grams. Do you see that? Because we have poured it all out, and once it hits here, there are 0 grams left. So it says, at what time does the machine reach 0 grams? Okay, so again, grams is your Y. What time? 3 minutes. This is just about reading it. Choose the statement that best describes how the time and amount of flour are related. Then fill in the blank. As time increases, so we're going up in time, yes, the amount of flour in the machine decreases. Okay, is that true? Or is it as time increases, the amount of flour in the machine increases? You can see here that it is decreasing over time. So it's going to be this one. And what is the rate per minute? This is tricky. Sometimes they'll tell you different values, like what is the rate per 2 minutes? So be careful. They're asking you the rate per minute. So all you need to do is figure out where this crosses. What is this point right here? And now you're going to figure out the rate. Rate is, remember, rise over run, and we go 1 on the 1. So we're going to go down 1, 2, 3. 3 times 70, which is 2100. If you take 630 minus 420, you're going to get 210. So it's 210 grams per minute. And that's how you answer that, just reading the graph. Just be careful about when they ask you about rate. All right, so now this is a problem about finding rate in a table. I had to cut off the title because I needed the rest of the problem. So what they're going to do is they're going to give you a table, and then they're going to ask you to figure out a rate. So just remember, these are points. So just in the way that you had slope, this could be x1, x2, x3, x4, y1, y2, y3, y4. They're giving you 4 points. You can use any 2 points to find the slope. So it says, let's see, this is just about reading it. How many flyers did Ahmad already have when he started printing? Oh yeah, this is a story about printing. Okay, he's printing flyers, and in 10 minutes he produces 87, 15, 112. Basically, that's the story. I'm sorry I had to cut it off, but you know because they're giving you a table. So how many flyers did Ahmad already have when he started printing? Well, they're not giving you that, you guys. Look, they're giving you after 10 minutes. So the idea is that you are going to extend this table to get it to go to 0. Okay? Wow, I just realized, I wonder if I can do this. Oh, I can. This is so cool. Let's see if I can do this. Ready? I'm going to do white, and I'm going to color over this. So we are going to try to extend this table. Okay, this is kind of tedious. It's kind of silly, but whatever. I'm trying it. So we're going to go backwards. Okay, let me get black. So we're going to go backwards. We're going to go here. Ooh, that was ugly. Let's try that again. Okay, there. And we need to go back in time. We don't want to start at 10. They're asking us to start at 0 when he started printing. Okay, so notice the x's are increasing by 5. So let's just go 5. And now I'm at 0. Woo! Now I need to figure out what are these doing. 112 minus 87 is 12. Minus 7 is 5. And then that becomes 9 is 15. Okay? 15. So this went by 15. Is this 15? I don't know. 112. 112 plus 15. 7. Is it 20? Oh, yeah, duh. It's 25. My bad. 25. Okay, this is why I got to check. So this is 25 here. Okay, 25 will get me to 37. All right, so the point is that you check to make sure that this is going up at the same rate. And it's a machine, so it's going to have a linear rate, typically. So 25. So let's go down by 25. 87 minus 25 is 52. Okay, and at 0, 52 minus 25 is 727. So how many flyers did he start with? 27. Choose the statement that best describes how the time and number of flyers Ahmad has are related. Then give the value requested. All right, so you're taking a look and seeing what's happening on the X right here. The X is increasing, correct? And what's happening on the Y? It's increasing. So as time is increasing, so are the number of flyers. So what does it say? As time increases, the number of flyers decreases. Well, no, that's silly. As time increases, the number of flyers increases. Yes, that is true. At what rate? Okay, at what rate? Well, again, remember the rate is y over x. Okay, change of y over change of x. And in this case, we're talking about flyers. So we are going up 25 flyers, remember, for every 5 minutes. We can divide that, and it's going to be 5. And it would be 5 flyers per minute, 1 minute. That's what that reduced to. Okay, because 5 went into 5, 1. So you get the idea. It's flyers over minutes. All right, a lot of this stuff is just interpreting and extending. Next, combining functions to write a new function. All right, a car rental company's standard charge includes an initial fee plus an additional fee for each mile driven. This is really typical, by the way. A lot of problems come this way. They'll be like, okay, they charge you this, and then this is the rate beyond that. And that is very typical of a car company anyway. The standard charge S in dollars is given by the function. So take a look. They're giving you an actual function. They didn't even make you figure it out, okay? Because that's what they're gonna, they basically want you to know what they're doing. What this says, okay, basically they want you to know what the equation is telling you. This is telling you that you started at $16.95, and for every additional mile, they charge you 60 cents. This company also offers an option to insure the car against damage. The insurance charge in dollars is given by the function there. Okay. Insurance is $3.90 and 25 cents for every mile. So let C be the total charge in dollars for a rental that includes insurance. Write an equation relating C to M. Simplify your answer as much as possible. Okay, so sometimes with these kind of problems, it's easier to start thinking about them in words rather than math. Okay, so the total charge. This is the words way to think about it. Look at what is the total charge going to be? Well, it's going to be, okay, the standard charge. Okay, the standard charge plus the insurance charge. You agree? Standard charge and the insurance. Got to pay for the car, you got to pay for the insurance. Now we're going to substitute in these equations. 1695 plus 0.6. I guess you could put 60M. I just put 0.6. That makes it money, 60 cents. Okay. Plus, we need to add on our insurance. Okay. $3.90 plus 0.25M. All right. Now you're going to add like terms. That's basically all this is combining like terms. So this becomes, sorry, I have to do it over here. 1695 plus 390 is 5, 18, 1, 10, 1, 2085. So you're going to get 2085. That's what you have to pay together, these two, plus every mile. Look, actually, I'm not going to jump. I won't jump. I almost jumped a step there. No jumping. Plus 0.60M plus 0.25M. Okay, and what would that be? Add that together and you're going to get 0.85M. Just so you can see it. 0.85M. And that is the total charge. And it says let C be the total charge. So that is C. Okay, so a lot of times, if you think about it in words and then substitute in the values, it makes it a lot easier. You can see here that they're literally giving you the definition of S. And they're giving the definition of I. Okay? And then all you needed to think about was, okay, I got to pay for the car and I got to pay for insurance. All right, this is about understanding functions and reading them in the different ways. So here you have a graph. Here you have a table. Here you have an equation. And here you have a description. So they're giving you 4 different ways that this can happen or be given to you. Okay? And now they're asking you to understand all of them. And it says, which function has the graph with the y-intercept closest to 0? There's no fast way to the end on this, you guys. Don't think like, oh my gosh, I should just be able to tell. No, you got to figure it out. What is the y-intercept? To find out which one is closest to 0, you need to figure them out. Well, look, right here, here's the y-intercept. Because on the y-intercept, x is 0. Here's the y-intercept. So that's 3 away. This is 2 away because it's at -2. Ooh, so this one's winning. Okay, this one's at 5. So that one's further away. And this one is at 4, which is 4 away. So the closest one is going to be this one. It's going to be function 1. Oops, that's function 2. Let's try putting on the right dot. There's function 1. It says, which function has the graph with the greatest slope? All right, well, you have to know the slope. So let's look and see. Do we have the slope? Well, here's the slope for this one. It's -2. Here's the slope with this one. It's -4. And by the way, when they say greatest, they are literally meaning the actual number. In other words, you could have -1,000, but if you have a positive 1, 1 is greater than 1,000, so 1 is greater. Okay? 1 is greater than -1,000. I don't know if I said that correctly, but yeah. So what's the slope here? The slope here is 1. We went up 1 over 1. Okay, this is the harder one. You have to figure this one out. What's y? What did we do? We went from -7 to -2. We went up 5. And then we went from -2 to -1 and up 1. So the slope is 5 over 1. So which function has the greatest slope? This one does because it's a positive 5. The other ones, this is 1 and those 2 are negative. So we're going to say function 4. Okay, now it says, which functions have graphs with y-intercepts greater than 4? Okay, again, you need to look at the y-intercepts, and in this case, we'll go back to blue because there they are. Greater than 4, -2 is not greater than 4. Function 3, that is greater. I had to cut it off, sorry guys. That is greater than 4. Okay, this is 3. Nope, that is not greater. And this is -4. Nope, that is not. It's only function 3. So you get the idea. You're looking at all different types. Okay, take a look. Last one. We are looking at the parameters, basically looking at like the limits in a linear function that models a real world situation. So Michael's putting money into a checking account. Okay, let Y represent the total amount of money in the bank in dollars. Let X represent the number of weeks Michael has been adding money. All right, so basically every week he's going to be depositing a certain amount of money. And Y is the total amount of money. Again, talking yourself through these problems is a very good way to work through the logic of it. It says, suppose that X and Y are related by the equation. So here they're telling you Y is equal to 40X plus 450. Okay, take a look just so you understand. This is the number of weeks because they told you that's the number of weeks. This is the total amount in dollars. Okay, it means he started with 450 and every week he's putting in, this is what the line means, you guys. Starts with 450 and every week he puts in 40 bucks. Answer the questions below. Note that a change can be an increase or decrease. For an increase, use a positive number. For a decrease, use a negative number. What is the change per week in the amount of money in the account? Change per week. When you see the word change, think of rate. Okay, think of slope. So the answer for that is going to be $40 per week. And it's positive because it's going up. What was the starting amount? 450. They want to make sure you understand your equation. And that's it for this one.